Let we see the introduction of the waves, chapter 1, class 12. In the chapter of 8th of first year, we studied the oscillation of the isolated object. What happens in a system, which is collection of such objects? A material medium provide such an examples. Here, elastic force behind the constitution to each other, and therefore the motion of one affects that of others. If you drop a pebble in a pond, still water, the water surface gets disturbed. The disturbance does not remain confined to one place, but propagates outer along a circle. If you continue dropping pebbles in the pond, you can see the circle rapidly moving outer from the pond. Where the water surface is disturbed, it is a tot of water is moving outer from the point of the disturbance. If you put some corks pieces on the disturbed water, the cork pieces move up and down, but does not move away from the center of the disturbance. This shows that the mass of water does not move outwards in a circle, but rather than the moving disturbance is created. Similarly, when we speak sound, that's energy move outward from us, but without any flow of air from one place to another. The disturbance produced in air are such less obviously, and only our ears or microphones can detect them. These disturbances, which move without the actual physical transfer or flow of matter as a whole, are called waves. In this chapter we will study such type of waves. Here waves represent transformation of energy, and the pattern of disturbance has information of its propagation from one point to another. All communication essentially depending on the transmission of signals via waves. Speech means producing of sound waves in air and hearing amount to their defection. Often communication involves different kinds of waves. For example, sound waves may be first converted into electric signals, which in turns may be generate an electromagnetic waves that may be transmitted through vacuum, air cables or any medium to a receiver. Detection by a receiving of the original signals will usually involve these steps in reverse order. Not all waves require a medium for their propagation. We have that light waves can travel through vacuum. The light emitted by stars, which are hundreds of light years ago, researchers have thought interstellar space, which is a practically vacuum. The most of family type of waves, such as waves on a strain, water waves, sound waves, seismic waves, etc. Our medical waves, these waves require a media for propagation. They cannot propagate through vacuum. They involve oscillation of constitution particles and depending on the elastic propagation of the medium. The electromagnetic waves that you will learn about, there are different type of waves. Electromagnetic waves do not necessarily require a medium. They are travel through vacuum. Light, radio waves, X-rays are all electromagnetic waves. In such, all electromagnetic waves have same speed, that c is equal to whose the value is that nearly the value is 3 into 10 to the power of 8 meter per second, the actual value speed. The third kind of waves is the so-called matter waves. These are very associated with constitution of matter. Electrons, protons, neutrons, atoms are the molecules. They arise in the quantum mechanical description of nature. Though conceptually more abstract than mechanical or electromagnetic waves, they have already found application in several devices based to modern technology. Matter waves associated with electrons are employed in electronic microscopes. In this chapter, we will study the mechanical waves which require a material medium for their propagation. The aesthetic influence of waves on arts and illustration is seen from very earlier times. Yet the first scientist analysis of the wave motion data back to the 17th century. Some of the famous scientists associated with the physics of the wave motion as Christian Huygens, Robert Hooke and Isaac Newton. The understanding of the physics of the waves followed by the physics of oscillations of masses tied to spring and the simple pendulum. Wave in elastic media are intimately connected with harmonic oscillation. Stretching string, coil, springs, etc. are the example of electro medium. We shall illustrate this connection through a simple example. Consider the collection of the spring connected to the one end as shown in the figure this. Okay, now in the figure 1 we connected one of the end is there. If the spring at another end is pulling suddenly, if another end is pulling suddenly and release, the disturbance traveling to one end what happened? The first spring is disturbed from its equilibrium length. Since the second spring is connected to the first, it is also stretched or compressed, and so on. The disturbance move from one end to another end, but each spring only executes small oscillations about its equilibrium position. As a particular example of this situation, consider a stationary train at a railway station. Different bogies of the train are coupled to each other through a spring coupling. When an engine is attached at one end, it gives a push to the bogie next to it. This push is transmitted from one bogie to another bogie without the entire train being bodily displaced. But let us consider the propagation of sound waves in air. As the wave passes through air, it compresses or expands a small region of air. This causes a change in density of the region. Say this change includes a change in pressure. Okay, now this includes a change in pressure. In the region, pressure is a force per unit area. So there is a restoring force proportional to the disturbance, just like in a spring. In this case, the quantity similar to extension or compression of the spring is a change in density. If a region is compressed, the molecules in the region are packed together and they tend to move out to the adjoining region, thereby increasing the density or creating compression in the adjoining region. Consequently, the air in the first region undergoes rarefaction. If a region is comparatively rarefied region, thus the compression or rarefaction moves from one region to another, making a propagation of the disturbance possible in air. In solids, similar agreement can be made. In a crystalline solids, atoms or group of atoms are arranged in a periodic lattice. In these, each atom or group of atom is in equilibrium due to force from one surrounding atom. Displacing one atom, keeping the other one fixed, leads to restoring force, exactly as in a spring. So we can think of atoms in a lattice as endpoints with springs between pair of them. In the subsequent sections of this chapter, we are going to discuss the various characteristics of and properties of waves. In the next video, we will see the transfer and longitudinal waves. So keep following.